Nice to meet you. This is the Hobby IT channel. Thank you for watching today. In this channel, it is a video that challenges making things with IT. Programs and circuit diagrams are available on the website below, so please make use of them. Let's have fun together.
This time, I would like to do an electronic work that acquires images with an IoT camera and saves them in Google Drive. The operation itself is exactly the same as the implementation using the Google Cloud API that has already been posted, but this time we will use Google Apps Script, so the technology is different, so we will learn. The content is very simple because it specializes in learning how to use Google Apps Script on a microcomputer rather than practical applications. I think that it can be used with other software regardless of the programming language, so let's understand this part first. In the future, we would like to implement practical applications for IoT cameras, such as entrance cameras. First, I will explain the overall flow of this work and the content covered in this video. As an overall flow, we will divide the outline and the specific work into 3 parts for understanding. Among them, this video deals with the overview and settings related to Google Cloud. The hardware and software are separate videos, so I will post the link in the overview column. Let's briefly understand what the 3 specific tasks are. The first is to make settings related to Google Cloud. Here, log in with a Google account and set it to Google Drive. In Google Drive, set the prepared script to Google Apps Script. The script can be copied from the Hobby IT site, so just paste it. This is the only setting, so it is much simpler than using the API. Second, it requires some electronic work on the hardware. Connect the microcomputer, camera, LED, etc. and work on the hardware. This time, I am wiring using a breadboard that allows you to freely change the wiring. Instead of suddenly creating a circuit diagram as a base, it is best to use a breadboard to create and study circuit diagrams on a trial basis while checking. The specific content is also uploaded in another video. The third is the program, which is software. How to operate IoT devices is determined by the program. This time it will connect to Wi-Fi on startup and get the image after connecting. After that, it simply encodes the acquired image with base64 and sends it to Google Drive with HTTP post. In order to understand Google Apps Script, it has specialized content. The specific content is also uploaded in another video. As I told you, this video explains the overall overview and the first Google Cloud setting. Regarding the hardware, it is the same as the content posted at the time of API. Also, since I have posted about software separately, I will post the link in the summary column. Next, as for the operation image, the IoT camera acquires an image with the camera when it starts up. The acquired image is saved to Google Drive in the cloud on the internet using HTTP post. Google Drive receives data using the preset Google Apps Script, decodes the base64 encoded data, and saves it as a JPEG image. You can check the images saved in Google Drive by using a normal method of checking Google Drive, such as a web browser or application. This time, I logged into my Google account with Chrome and checked inside Google Drive. Now let's see it in action. Here is an IoT camera using ESP32 and OV2640. It is wired with jumper wires on the breadboard, and the program has been written and completed. The Arduino IDE serial monitor is displayed in the upper left, and the file status of Google Drive is displayed in Chrome in the lower right. Now let's get it working. Clicking the restart button restarts the ESP32 and captures images with the camera after booting. You can see that the log at startup is displayed sequentially on the serial monitor. Acquired images are uploaded to the Google Cloud on the internet via Wi-Fi via HTTP post. Once uploaded, the image file will be displayed in Google Drive. As you can see in the lower right, you can see that the Minions image captured by the IoT camera has been successfully uploaded and saved to Google Drive. This time, it will be the production of the IoT camera that has been operated. Next, there are 2 main ways to save files to Google Drive as shown in this figure. There is a method using Google Apps Script, GAS, and a method using Google Cloud API, API. The operation itself of saving images to Google Drive can be realized in exactly the same way in both methods. It depends on the purpose, but if you want to try it once but don't know which one is better, I think API is better because it is more versatile, including application to other Google services. However, the API is more complicated for Google Cloud settings and authentication methods, so I think many people find it a little difficult. I think GAS has a simpler and easier to understand overall mechanism, and the Google Cloud setting itself is easier. This time, it will be a method using GAS. If you want to know how to use the API, please refer to the link in the overview column as it is posted separately. That's all for the overview. From now on, it will be a concrete task. Now, let's do the first Google Cloud settings. First things first, log into your Google account in your web browser. Start from this state. I am using Chrome as my web browser. Click the icon on the top right to display the list of services. Select Google Drive from among them. Next, select a folder from the plus mark new on the upper left and create a folder. In particular, the folder name can be anything, but the created folder name and the contents of the script to be set must match. This time I gave it a name like this. Give it a name and it will be created. Similarly, select Google App Script this time from the new plus mark on the upper left. Once created, give the project a name. I don't mind anything in particular. I chose this name this time. Next, we will create the script. Copy the script from the Hobby IT site. Paste what you copied here. The folder name is set, so if you change it, please match that part as well. Save this when you're done. Next, we will deploy. From the Deploy button on the top right, select New Deploy. Click the Settings icon on the top left and select Web Apps. Next, you will be asked to enter your name, so enter your name. Also, select Who has access so that everyone can access it. Once completed, please deploy from the button on the bottom right. Next, we will set up access authentication, so please click this button. Specify the Google account for access authentication. Be careful, but click the button on the bottom left. Details will be displayed, so click the forward button at the bottom left. When this screen appears, click Allow. The settings are now complete. The ID and URL will be displayed, so copy them to Notepad etc. Script is set to HTTP GET for testing. Therefore, we will test using the copied web app URL. Create a new tab in your web browser and paste the URL of the web app into the access destination. If it is displayed like this, the Google Cloud setting is successful. If it is not displayed, there is an error in the settings, so please respond according to the error. The configuration itself is now complete, but let's understand the script next. Here is the script that is set this time. I am setting the functions for do get and do post. This is a function that is executed corresponding to HTTP GET and POST, and is a function that is predetermined by the Google App Script specifications. Since the image is saved with POST this time, there is no need to set it for GET. It is provided only for checking with a web browser whether the settings have been completed successfully. If you describe the URL in the access destination of the web browser and communicate, it will be requested as GET, so do get is set. Originally, unnecessary processing is performed, so it is not desirable from a security point of view. If you do not need confirmation, please delete the do get function and set it. As for the processing of the do get function, if there is access, do get completed is simply output as text. If this character can be confirmed with a web browser, it is working normally. Next, let's check the do post function. On the 6th line, the data received by post is decoded in base 64. If binary data such as image data is sent and received as it is, there is no use of delimiters, etc., so there is a possibility that the header and data cannot be separated clearly on the receiving side. So I am sending it with base 64 encoding and decoding it after receiving. Next, line 7 generates the file name to save from the current date. Since it is a file name, an extension is added at the end so that it can be recognized as a JPEG image. The 8th line is setting for handling files. Lines 12 to 17 are looking for a folder to save to. Searches for a folder that currently exists with the folder name, and if the folder does not exist, it is newly created on line 16. The received data is saved as a JPEG image on line 18. Line 19 is a process that simply outputs do post completed as text. That's all for the understanding of script. Now you have understood the Google Cloud settings from the overview and the script you set up. That's about it for this video. After this, in order to complete the IoT camera, it is necessary to work on the hardware and software, but since it is a separate video, I will post the link in the overview column.
We will continue to take on the challenge of making things using IT like this, so please give us a high rating and subscribe to the channel. See you next time.